All right, so let me give you a problem, and we're going to work this together, and then we'll get a chance to practice a little bit. Perhaps as homework. We'll see how the time goes. So let's say we have 2.25 grams of silver nitrate. And we're going to dissolve that in water. Then we're going to react that.
So say
and R, A-R-E. Going to react that with 2.25 grams of sodium sulfate. Which has also been dissolved in water. What is the limiting reactant? That's a number 1. All right. First thing we need to know, what are the formulas for these two compounds? Now you should know that. You should be able to figure that out. So if you'll write the formulas for those two compounds. Write the formulas for those two compounds. If you're listening on the video, each student has a set of test references that they'll use then to find the parts of the compound. Silver, they can look on a periodic table to find its atomic formula. Then they have a periodic table with oxidation numbers where they find the oxidation number on the silver. And nitrate, that ATE ending is a signal that you've got a polyatomic oxyanion. And so I hope that all my students are now looking on their common ions list to find the formula for nitrate. And then with the charge on the silver and the charge on the nitrate, they'll figure out how to write a balanced formula for that compound.
Mr. I have a question.
Yes, what's your question?
What age group are you trying to target these videos?
High school students. Why?
Well, I mean, that's probably the last thing I'll do is go on YouTube and look up chemistry.
Really?
No.
I mean, art school.
Okay.
I've done it before.
Well, it's there for you.
What's the names
Right.
of your videos?
Well, don't just do this work. You can find the names of the videos by going on the website and clicking on them. Okay? It's primarily there for students in my classes to review, to catch up when they're out, absent. Are you listening, TJ? I'm answering your question. Okay. So, for instance, I had a student who was out in CP. Well, it turns out you have to be just about the same place as my CP class right now in this material. So I'm going to use this video for both CP and honors. Okay? Although, when we get to a little later in this unit, you'll be doing some things my CP class doesn't have to do. Okay? Well. Did you find the formulas for both? All right. Who has not found the formulas? Raise your hand. Let me know where you are. All right then. So silver nitrate. Silver has a 1 plus charge and nitrate has a 1 negative charge. And so one of each is going to give you a balanced formula. Yes, and it's going to be aqueous. You could look it up on the solubility rules, but I tell you it's dissolved in water, so you could just assume then this is one case where it's not really an assumption. It tells you it's aqueous essentially. And then sodium and sulfate. Sodium has a 1 plus charge. Sulfate, there's that AT ending, tells you have a 2 negative charge. When you look it up on the common ions, this is 2 negative charge, so we're going to need 2 sodiums. And when you look on the solubility rules, you'll see that most sulfates are soluble. Huh? Okay. So it is dissolved, yes. It is dissolved in water, you're right. All right, now, if I have 2 compounds that look like this, and you can look at the names and get a clue, these are like 2 two-part compounds. So what's the most likely kind of reaction we're going to have? Double replacement is correct. And so for double replacement, you need to be able to predict the product. So please...
Double replacement, double displacement.
Double replacement is the most common term, although I have heard it called double displacement. Okay, double replacement. Okay, please find the products. Please find the products. Now remember, subscripts only travel when they are part of polyatomic ions. I hadn't asked you to balance it. I just wanted you to predict the products and then balance the formulas. Yeah. Yeah. Everybody got the formulas balanced? Who's still working? Raise your hand. You got it? Ashley? You finished? Okay. So silver has a 1 plus charge. You can find that on the periodic table with oxidation numbers. Sulfate has a 2 negative charge. So to make that a neutral compound, you need 2 silvers. Sodium has a 1 plus charge. Nitrate has a 1 negative. One of each will give you a neutral compound. We need to find the physical states for that. Have you already done that?
Yeah. What are they? Solid and aqueous.
Okay. So most sulfates are aqueous, but silver is one of those exceptions. If you look on the solubility rules, it tells you sulfate's mostly soluble, but not when it's combined with silver. Nitrates and group 1 salts are always aqueous, so this is always aqueous. Okay? All right, so we've got balanced formulas, and now we're ready to balance the equation. So can you balance the equation, or would you please balance the equation? Now, whether you want to or not, balance it anyway. Okay, did everybody get the coefficients that I got? No? You make an error somewhere along in the process, William?
I did it wrong the first time.
Oh, okay. All right, good. Now that we've got a balanced equation, now after all this time, we're ready to start the stoichiometry, the new thing. Okay? All right. When we're doing stoichiometry, we started this last week, we always started by putting starting amounts over 1. However, when you're figuring out a limiting reactant, either one of the reactants can be the starting amount. So we have silver nitrate. If it's on the left side of the equation, that's a reactant. Silver nitrate is a reactant. Sodium sulfate is a reactant. To figure out the limiting reactant, either one of those can be the starting amount. Does anybody have a preference? Do you just like silver nitrate better?
Yeah, I have because it's
All right.
shiny.
Okay. Well, no, silver nitrate's not shiny at all. Silver nitrate's the stuff that looks kind of, almost looks, depending on how new it is when the solution's made up, but it looks clear in the bottle, but it turns your skin brown. Yep.
What exactly is a limiting reactant?
Okay, I can give you the definition of a limiting reactant right now. The limiting reactant is, yes.
Why did definitions change as we get farther on?
Well, sometimes we make them more specific. Okay. For instance, we define salts early in the semester as something that combines a metal and a non-metal, or it contains polyatomic ions, but we excluded oxides from that list. When we got to enough acid-base theory, we define salts as something formed from the reaction of an areneous acid and areneous base. That'll give you a much better result for what a salt is. Okay. For a chemist, that second definition makes more sense. For most of the definitions we use in here, we're not making them different, but we are making them more specific as we go along as we need them. I don't try to give you a more specific definition that you can't understand yet. That makes sense? All right, so a limiting reactant is one of the reactants that runs out first. And it's called a limiting reactant because when the reactant runs out, the reaction has to stop. Okay? Think about burning something. The two reactants when you're involved in combustion, at least the simplest form of combustion, is you have a hydrocarbon fuel and oxygen. How do you stop the fire?
You don't.
Lack of oxygen.
You cut off the oxygen. That's right. So that's in the case of stopping a fire, oxygen is the limiting reactant. Once you cut off the oxygen, the fire can't burn anymore. What now? You could take away the hydrocarbon, but generally when you put out a fire, you rob it of oxygen. Okay? You were right the first time. Okay. So,
How do we tell what the limiting
that's what we're going to do. We're going to figure it out now. We're going to calculate. We're going to do some calculations to figure out what the limiting reactant is. Okay.